Next up, we have the very awesome Gil Tayar, and I'm going to read his bio, but I'll tell you a few anecdotes about him too, because I actually know him personally. So Gil, who is today, um, Hey there,
Hi,
Gil.
Darren.
So you actually call him Guru Gil, and I'll tell you why shortly. My guru. Um, but yeah, so from the olden days of DOS, Gil was, is, and will be a software developer. He has co-founded Web Collage, survived the bubble collapses, and designed cloudy projects at Wix. His current passion is figuring out how to test software, a passion which he has turned into his main job as senior architect at Apple Tools, where he develops tests for software that tests software. Haha, you tried to trick me there, which is almost one meta layer too many for him, even. But let me tell you something about Gil. Gil is capable of getting 500 people to sing along to his talks at conferences. Are you not, Gil?
Yes, it's
This is
a
a very
passion of
special
mine.
talent.
I love doing that. Yeah.
You're
You
like,
try
I don't want
once.
to be the only one who's embarrassed on stage. I'm going to get all of you to embarrass yourselves with me, right? So Gil is an excellent speaker. You're going to enjoy this talk. And Gil, I want you to keep in mind for the questions how this applies to science fiction.
Oh, I'll probably find a way.
All right, let's roll it and prepare your questions for the very awesome Gil who is with us today.
Thank you.
Four pillars and a base, the nuts and bolts of a monorepo. Everybody's talking about monorepos these days, but you're giving me 55 minutes to talk about monorepos. So I want to talk about monorepos from my own personal viewpoint, and that is pretty much 6 years, give and take, of working with code on monorepos. And I wanted to convince you this. I want to convince you that multi-repos, which are the inverse of monorepos, we'll talk about that. Multi-repos are okay, but monorepos are great. Even though they may be difficult to manage, when I'm going to talk about those difficulties, I think that if you really want scale and if you really want what I call frictionless development, they are totally, totally worth it. So, hi, I'm Gil. I am so happy to be in Verona, even virtually. I go back all the way to the 80s. I'm pretty old. DOS, Windows, the beginning, everything, the whole shebang. I was there. Anyway, I tried the whole startup, CTO, founder thing. Found out I didn't like it. I was, and probably always will be to the day I die, a developer. And testing the code I write is a passion of mine. I test everything, and we'll talk about that in this talk. So it's not nuts. Huh? Anyway, I'm currently a developer advocate and an architect, software architect at Apple Tools. Apple Tools delivers visual testing tools. So if you're serious not about only about how your functionality works, how your app works, but how it looks like, please check out Apple Tools Eyes. I'd be happy to talk about that. Anyway, multi-repos, the inverse of monorepos. What are multi-repos? Multi-repos is where you have a few monolithic apps or one app. In each has its own Git repo, and maybe you have some more packages, but there aren't a lot. And each of the packages, like the common or whatever, has its own Git repo. So let's take a standard application. It has a front end and a back end, and you have two repos, one for the front end, one for the back end. Yes, I know that some of you combine the two into one repo. So this is a standard app with two repos, a front end and a back end. And a lot of times we have common code between the front end and the back end. And since we're using, like, say, Node and front end is JavaScript, then we can create a package with common code, lots of time called utils. And front end always, we now have design systems, so a component UI library. And each one of them is a separate package. And since they're a separate package, they're also a separate Git repo. And we know that common code, it tends to grow and grow. The trash can, I call it, of common code. We'll talk about that. I think it's important. And what about backend? The backend, well, today we have microservices. So a lot of companies take that backend app and boom, turn it into a set of microservices, or starts immediately from set of microservices: authorization microservice, payment, email, two emails, app microservice A, app microservice B. All of them use common code, and there we go. We have the backend as a set of microservices, and each microservice, as usual, is a package with one Git repo each. And unfortunately, microservices need common code as usual, so they all have common microservice code, like the framework for the microservices, or logging, or whatnot. And that's also a package, so that's also a Git repo. And there's authentication and payment, etc., and there's the app code, and that also sometimes needs its own common app code, so that's also a Git repo, also a separate package. That's usually the whereabouts of one app companies, this amount of Git repos. Not a lot. Definitely manageable. What about multiple apps, where a company has multiple apps or multiple projects? Well, then boom, we have more and more common code, more and more Git repos, and sometimes a lot of these apps have all of these apps have even commoner code, or a design system for all of them, and those are Git repos too. But this is manageable. This is okay for this scale, like 3 apps, 10 each. We can live with that. It's okay to have a repo per package, a repo per app. Why? Why is it okay? Why not just throw everything into one big repo, a monorepo, and just deal with it that way? And the answer is the benefits outweigh the problems, because there are problems, and we'll talk about that. Everybody understands the one package, one repo model. It's like, open source works that way, and all our tools are open source focused in one way or another, so they're all built for that. One package, one repo. You do a change, you commit, you push, you publish. Everybody understands that. A CI is easy. Issues is easy. If you're using GitHub issues, then all the issues are for the specific package. And CI is easy because CI is built for that one package, one repo model. So you have one job per repo, a build job that builds that repo, and when you commit and push, then that is triggered. It builds that repo, runs the tests, and boom, you have everything you need. Modern CI is built for this model of one package, one repo. It's just built for that. But at some scale, at some level, problems start to arise. And we'll talk about that. Let's talk about main 3 problems, because there are a lot of problems. First of all, at a certain scale of code, the CI build times become horrible. Packages are monolithic, basically. So if you have one app, a front-end app, then all the app is in one repo, and build times are getting larger and larger, because you're adding more and more code and more tests. So the build times become complex. The testing time runs, and even if what you changed was a small thing, which didn't affect everything, it doesn't know, so it builds the whole thing. It runs all the tests, and etc. So that's for me one of the biggest problems here. It's an all or nothing. You build huge repos. 2, dependency tracking, because you have a package changes, which packages need to be built? How do I know if one package changes that other packages need to be built? For example, common app code, if that package changes, I need to deal with the app microservice A and app microservice B code. I need to build those packages. Standard CI can't deal with it. And there's this new workflows feature. It doesn't help, because everything in CI is per repo. Face it, standard CI was built for monolithic code. One package, one repo. And creating a new package in a multi-repo world is difficult. It is incredibly difficult, because to create that new package, we need to create a new Git repo. So that's finding the person with enough permissions for that in the company, and then fill it with all the boilerplate, the npm, the package JSON, whatever. Then create a CI job. You have to find a person with enough permissions for that, and build the correct Jenkins job if you're unlucky, or if you're using modern CI, then a YAML file. And you know how all that goes. You create the YAML file, you push, it doesn't work, etc. So every package is like a 2-day work, without even starting the code itself. So creating a new package is difficult. So basically what just developers just don't do it. I mean, they just don't create new packages unless the benefit is really, really huge. So, and the corollary is, and this is an important corollary, splitting a package is difficult because splitting a package means taking one package and turning it into two packages, which means a new package. So let's take an example. So we have the front-end app and we have the component UI library. Okay, we split the component UI library Y, one to promote reusability. So if we have two front-end apps, they can use the same component UI library. This is great. And two, modularity is good. In essence, I mean, the more modular your code is, the better it is, and we'll talk about that a lot later. But now app A wants more components, wants to add more components. So theoretically, they should create app A specific components and not part of the component UI library, but that means creating a new package, and we saw how difficult it was. So create a new package, forget about it. I'm not going to do that. Nobody's going to do that. So what do? They just throw it in the component UI library. It's the easiest. Everything is there. The build system, it just works. You just throw it in. So what if nobody else but front-end app A uses it? Well, and you know what happens is they see that it's nice, and they add more, and they add more, and they add more, and they add more, and suddenly we have this component UI library, which started out as a nice one, and now it has all these hundreds of components that nobody can find their feet and legs and feet in. Hands and feet? Whatever. So yeah, welcome to the world of monolithic code. Welcome to the world of multi-repos, where even creating a new package is difficult, so modularization of that monolithic code is impossible. And what is wrong with monolithic code? Well, everything. I think it's hard, and we'll talk about that. Hard to understand, hard to navigate, slow to test, and hard to modularize. Let's start with hard to understand and navigate. Because the more code you have monolithic, the harder it is to navigate. And if you find yourself in Visual Studio Code and you have like hundreds of files, you need to figure out who's against who, where's the entry points, where's the exit point, what is the common code, what isn't the common code, etc., etc. It is very hard to navigate in, and it is very hard to understand. It's slow to test. The more code is in the repo, the more tests there are in the repo. Now, notice the COVID-19 reference here. That's my favorite. The more tests there are in the repo, the more tests they need to run in CI. And even if your change affected only a small piece of code, you still need to run all the tests. And the worst thing is, if you did a small change and you want to see whether all the tests work, you don't do that because it takes half an hour. So you just let CI do it. And then, you know, you have this cycle of, oh, it didn't work in CI. Oh, I found the bug. Push. Oh, it didn't work in CI. Yeah, I'll fix another bug, etc. It's like push-driven development. It's very slow to test. And for me, the worst thing is it is hard to modularize. When each module can call all others because they're in the same monolithic, package, they tend to do so everywhere. And you get basically spaghetti code. Hey, I'm in Italy. Hey, well, you get basically spaghetti code because developers can, and when developers can, and the dependencies are implicit and not explicit via npm dependencies, what will happen is that everybody starts calling everybody. To summarize, multi-repos are okay up to a certain scale. Multi-repos are easy to set up, but after a while, they don't scale, and you've seen it time and time again. You start a project, everybody's running, everybody's really, really happy with their stuff. And if things are going well, features are bouncing out of your code and everything. And then slowly, as the code accrues, as more and more developers are added to the team, as more and more teams are created, everything starts to feel like walking in the mud. And the main reason, it's not monorepo, multi-repo, it's modularization. It is the fact that your code is not modularized, and every change is a global change, and we'll definitely talk about that. But what if we could create many packages easily, hundreds of packages, just like that, and build them easily, so no need to create a CI job? And what if creating a package was like 10 minutes, 5 minutes, 2 minutes? And if you want to split a package, easy. Just split it into a new package and you're done. and CI works and everything just works. What if we could do that? And that is exactly what a monorepo allows us to do. A monorepo, in my definition, and there are many definitions of monorepos, it is a set of many packages, hundreds, easily built in one source code repo. And this is the definition that the behemoths use. The Googles and Facebooks and I think Twitters of the world, they have one repo with all the code of the company. That's a humongous monorepo. I'm not talking about that. I don't even know how to approach that scale. But a company-wide repo where all the code is there for a small or medium-sized business, I think it's a really good thing. So this is a monorepo. So this is your monolithic code. It's just one big blob of code. This is what usually people have, maybe 4 or 5 packages. But this is your code in a monorepo. A lot of small. We'll talk about what exactly are the attributes of packages in a monorepo. But, and this is very, very important, not all monorepos are created alike. There are good monorepos and there are bad monorepos. It's like microservices. The fact that you move to microservices, or the fact that you move to micro front ends, or the fact that you move to React does not fix all your problems. The fact that others moved to it and it fixed all their problems does not mean that you will get it. So just moving to a monorepo may be worse than working in a monorepo if you don't follow the rules and the best practices. And we're going to talk about that. The good ones, the good monorepos that definitely do help scale and do help development become like monotonic, frictionless development, the good ones are built on 4 pillars and a base. So let's talk about what those 4 pillars are. So monorepos, good monorepos, stand on 4 pillars. The 4 pillars of monorepos are small packages, independent packages, tested packages, and uniform builds. And we'll go talk about each and every one of them. And these 4 pillars enable the base. And the base is frictionless development. What does frictionless development mean? Some call it scalable development. I like the frictionless thing better. It's nicer. Frictionless development means that you can add code, delete code, refactor code without fear. Just by adding a feature. It's just adding code, running the tests, building, publishing, deploying. It's like this boring, I'm putting air quotes here, boring, monotonous development cycle where you just add features and they just get added and there's no friction, no problems with other team members. Of course, nothing's ever that easy, but at least remove as much friction as you want that shouldn't have been there in the first place. Let's talk about the 4 pillars. Let's first talk about small packages. Okay, small packages. And why do we need small packages? Well, the answer is we are human. Well, at least I am. Okay, and as humans, when things are too big, they become incomprehensible. We saw that in the monolithic code. It's hard to navigate. It's hard to understand. You need to understand everything before you understand anything, and that is difficult. And it's the reason, because we're human, because too big is incomprehensible, it's why we invented divide and conquer, modularization, because we're human and it's just too big. Okay, there we go. So, rule number 1 of monorepos: divide your code into many packages. And the question is, how small or how big should a package be? And there's always a balance between too small and too large. Always. I mean, if it's too small, we get left pad. Remember the left pad incident where the whole NPM ecosystem crashed to a halt because somebody deleted left pad? Well, it's an extreme case. Usually it doesn't happen, but packages as small as left pad usually shouldn't exist. There should be something bigger, like a set of utilities around, let's say, string manipulation. That's fine. But What about too large? Remember your utils package, which is basically a trash can where you just throw all the common code in and then nobody can navigate inside it? That's the inverse. That's the problem. Not to mention your app, which is like 50K, 100K lines in one large repo. That is definitely inconceivable. So you want to strike a balance between too small and too large. And the balance is more towards don't let it grow. I mean, our inclination is to just add one little more. Well, just add one more. Even if it's easy to create a package, we just to add one more thing, okay? So don't let the left pad incident, which everybody says, oh, don't build small packages, don't build small packages. Don't let that incident rationalize your laziness in building huge packages. And the answer is build them as small as possible, but no smaller. I always tend to think of it as limits. So if the number of tests grow beyond 3 minutes, okay, then maybe there's too much functionality here. Just start, splitting it into a separate package with sub-functionality. Maybe if the code goes above 5,000 lines of code, I don't think where it becomes incomprehensible, well, let's take part of it, just split it into a separate package, okay? It's up to you. We're human and there's no real guidelines. But if something becomes too big, you know it. I mean, everybody knows when a package becomes too big. Everybody knows when something becomes too big. It's just that they're lazy, or in the case of multi-repos, it's basically impossible to split it up. But monorepos enable you to do that easily. And we'll talk about how later. What will this enable? Well, and once you have a lot of small packages in a monorepo in your project, instead of like one big monolith, then a developer doesn't need to understand everything to understand anything. The developer doesn't need to understand all the code all the time. And small packages, I call them just-in-time understanding tools. You don't need to understand all the packages. You just need to understand the relation between most of them, some of them, or clusters of them. And if you suddenly need to go into a package, then, just understand it then. Just-in-time understanding. Only when you need it. And once you need it, it's a small package. So it's easily understandable. Well, easily. Not always, but as easy as you can do it because it's small. Because you can look at the tests and see what they do. It's not too big to be comprehensible. This is crazy, crazy, crazy important. And monorepos allow us to do that. I mean, you could do it in multi-repos, lots and lots of Git packages, but can you really manage hundreds of Git repos, each one with a separate package? Remember the dependency tracking? No, it's just not possible. Okay, monorepos allow you to do that. And I know it, and we'll see later. Okay, second one. Independent packages. We talk about small packages, but they also need to be independent. And this is your code in a monorepo. Lots and lots and lots of packages, right? And remember, we're only human, okay? Then it all comes back to that. You can't focus on it all. So if you need to change something, you usually need to focus on one package, maybe two. Usually when you're adding a feature, it's just one package or two packages. And the best way, if it's more, than to add piecemeal wise. Just first one or two packages, push, then another two packages, push, etc., until the feature is done. But usually on a certain day, you need to focus on one, possibly two packages. And to be able to focus on a package and work on it and understand it, it has to be independent. And what does independent packages mean? First of all, independent source. No source code dependency on another package. So you can't require, because remember we're in a monorepo, so theoretically we can require ourselves into another package. Not allowed. No source code dependency on another package. If you want a dependency, use npm. I mean, that package is going to be published or was published. So just use npm regular dependencies, even if it's in the same repo, and require it using like regular dependency requirement. So remember, no source code dependency. Why? Because if you start source code dependencying things, they're not independent, and you start, using everywhere from everywhere, and you can't track which packages use which other packages. And basically you're back in spaghetti land again. And as much as I like to be in spaghetti land when I'm talking about food, I am not going to go back to spaghetti land when I'm talking about code. Okay, So independent source, once you have that independent source, then you can get independent understanding. You can understand that package because everything you need is in that package. Yes, there are dependencies on other packages, but usually because those dependencies are not source code, they are loosely coupled. And independent source even tends to generate packages that are loosely coupled because they're small and they're independent, and you need to have everything in it to run. So the connection to other packages are usually pretty loose. So they tend to generate packages that are loosely coupled, but not necessarily. You still have to think and design carefully so that the package connections are loosely coupled. It doesn't come for free, but it definitely helps. Okay, independent source we talked about. What about independent builds? Can you build a package independently of other packages in the repo? Can you code it independently? Lint it, transpile it? When you see it in VS Code, is it independent, or do you need to install other stuff to work on it? Do you need to have the other packages there, or is it an independent piece of code that can be built independently? Can run the test? Can you run the test in the package independently of the other packages? This is very, very important. And can you publish the package independently? That's independent builds. And independent builds enable you to work in the package without thinking of other packages, and code in the package without thinking of other packages. And that is why Yarn workspaces and Lerna in that regard, okay, is really bad. You can't really install one package. You just can't Yarn install just one package, because you have to install all the packages in the repo, because that's how workspaces work. Okay, yep. And independent builds mean independent coding. And when you're doing independent coding on a small piece of code, that's easier. And that's part of where the frictionless coding comes from, frictionless development. Because when you're doing something on an independent set of code, it's much easier than code that has lots of dependencies and you don't understand what's going on. And this is crazy important. But there's a necessary condition which we didn't talk about for independent package. For a package to be independent, we need something. We need the package to be well tested. And that is the third pillar. We saw small packages, independent source and independent build packages, and now well-tested packages. Very important. Maybe the most important of them all. And you know how much I like tests, so take that with a grain of salt. Anyway, if we want a package to be coded independently so that we can go in, understand what the hell is going on, and just write the code, we must ensure that all the changes we write do not break previous functionality. If I'm going into a package that I've never seen before, and that happens a lot, I want to go in, change the code, and be sure that I didn't break previous functionality. That is very important. And the only way to do that is to write tests. The only way, okay? And the tests have to be independent because, hey, we're in an independent package. So yeah, know those big end-to-end tests that we have where we build the whole app and then automate the browser to check that everything works. We run the database and we put it in a staging environment, etc. Out. Take that out. Well, they have their place in the world, okay? I mean, big end-to-end tests are definitely important to understand that the whole thing works. But when talking about the package and coding in that package, big end-to-end tests are out. I can't change a package and then run the big end-to-end test to just check that things are working. Big end-to-end tests break independence of packages. So when coding in a package, don't do big end-to-end. Do small end-to-end, and we'll talk about that in a second. Go ahead and write tests. Go ahead and write unit tests, integration tests that tests only that package, and write what I call small end-to-end tests. So if I have a package which is a microservice, then a small end-to-end test just runs it as a Docker container and just tests it as a Docker container as if it was in production. I call that the small end-to-end. And since we're talking about small packages, we're not talking about huge packages, unit tests tend to be not as important as in monolithic code. I prefer in my packages more integration tests, because integration tests integration tests have a problem. They test the whole thing, okay, or like most of the thing, and in monolithic code that's very difficult, but in small packages that's pretty easy and makes unit tests somewhat less necessary. And I am sorry for all the TDD fans out there. So I prefer the diamond of testing when using small independent packages. Kent Dodds calls it the trophy of testing, a very similar idea, small unit, lots of integration, very small end-to-end tests. Okay, and the interesting thing is that independent packages where the package is self-contained, all the code in it is self-contained, means that when I write code in that package, it's very difficult to test it manually because I can't really run the app and test it manually because I'm working only on that package. So in essence, when I'm writing code in independent packages, the only way to test that that code works correctly, is to write a test. So an amazing side effect of independent packages and tests is that developers write many tests. They have no choice because they're working in independent units and they can't test it like, okay, I did this change, let's run the application and check that it works. No, you can't do that when you're talking about independent packages anymore. There's no other way to test the functionality except for tests. So independent packages need tests, but make it not easier, but make it important, almost crucial to write tests because there's no other way to test the functionality that you've written. And this is the holy grail for me. I mean, something that forces a developer to write tests, there's nothing that makes me happier. As you know, I'm a testing passionate aficionado. And well, this has nothing to do with monorepos, but it's one of my favorites. How do I know I wrote enough tests? People swear by coverage. I'm not a big fan. I think coverage is a false metric in most cases. I prefer the shakeometer. How does intuitively, how much does my hand shake when I press enter to deploy or to publish that package? If it starts shaking, then it's probably because my intuition is telling me that I haven't written enough tests. And you know when that happens. You know in your heart that you haven't written enough tests. So put a shakeometer to your wrist, check it. If you're afraid of pushing that, publishing that package or deploying that microservice or deploying your front end, go back, write more tests, and then do it again. Okay, small, independent, well-tested, now uniform packages. I like this quote. All happy families are alike. Each unhappy family is unhappy in its own way. This is the starting sentence of Tolstoy's Anna Karenina. My paraphrase of that is, all happy packages are alike. Each unhappy package is unhappy in its own way. And all our packages are happy because they are the same. They are uniform in the way we build, test, and publish them. And they are the same in their folder structure. It's this SRC, test, etc. We have a very consistent folder structure. That's optional, though. That's optional. I think it's a great idea, but it's optional. Let's talk about build uniformity, mainly build uniformity. Well, first of all, what is a package? We talked about packages. We really didn't define it. For me, a package is source code that can generate artifacts which are used by other packages or in production. Like, what are you talking about? So let's take two examples. First of all, the regular package that we know about, library packages. An NPM package. The artifact of the source code of this package is an NPM package that is published to our NPM repository. So if I have a string utils package, the artifact is the package in the NPM repository which other packages can use via NPM dependencies. Okay? So that is the artifact of a library package. A microservice package has lots of artifacts. First of all, an NPM package in the repository, so maybe for testing purposes, other packages can use it as a library, not as a Docker image. But the most important thing is the artifact of a Docker image. A microservice package generates an artifact, a Docker image, to be used in production. That is what is going to be used in production. And maybe configuration files to be used in production. And all our packages our npm packages, which and the build goes this way. First of all, npm install or npm ci for nci. Second, npm update. We update dependencies to the latest because some of our packages may have been updated, and we always like to keep track and always be in the latest to avoid security issues. And really, it's not that difficult. I mean, it just works. I mean, very rarely did we get a problem because of npm update. npm run build the artifacts. I mean, we're JavaScript people, but if you're using TypeScript, then npm run build will, build the TypeScript. In our case, for microservices, npm run build will build the Docker image, and then npm test to run all the tests. If all these pass, we publish the artifact. In this case, we use post publish if it's a microservice to publish the Docker image and whatever other artifacts. And when we want to deploy the package, like say it's a microservice, we do npm run deploy and pass around all the parameters we need to deploy it, but that's secondary. Let's take an example from a library package. So these are the scripts in the package JSON. Build, we're using JavaScript, doesn't do anything. Test runs lint and then runs Mocha, where Mocha runs all our unit tests, etc., etc. Very simple. A microservice package is more difficult. A build does npm run build Docker, and the build Docker just builds the Docker image. Test runs lint and then Mocha, just like we saw previously, and publish just publishes the Docker to the Docker repository that we have. And the advantages are really good. Developers can start developing all our packages without understanding anything. I mean, they know how it's going to be built, and we use scripts to run that build, and CI can treat all the packages as the same. It doesn't need to understand which package is different and what not. So again, creating a package is really, really, really easy because just put it in and the CI knows about it. Disadvantages, sometimes it's like fitting a square into a circle. Mostly no. Mostly it isn't a problem. And this is what is part of frictionless development. Boom, you go into a package, you understand what it's about. There's also source code uniformity. All our packages look the same. They have a scripts folder and a src folder, and they have the package JSON, which looks very similar, and the Docker file, and the ESLint RC, and the git ignore, and whatnot. Launch JSON, everything. And how is this possible? Well, they're generated by npm init. npm init add applitools, and then we say whether we want a library or an app or a CLI, and we have these templates which we go through with mustache and tweak the name and all that kinds of stuff, and we, like, in 5 seconds we have a fully installable and runnable app, a web app or a library or a CLI, and just npm install, npm run build, and it works. It does nothing, but it works. So there we go. These are the 4 pillars of Monorepos. Small packages, independent packages, tested packages, the most important thing. I mean, without this pillar, everything falls. You can have small, independent, and uniform packages, but if you haven't tested each package, you will be afraid of pushing. And when we get to the day-to-day life in a Monorepo, you will see that that is a huge problem. So if you're not into tests, don't go the Monorepo way. And all these, as we said, give you frictionless development. Let's talk about a day-to-day in a Monorepo, and this is really how our day looks like. It's almost boring. It's not, because the stuff we do is interesting, but at least we don't get bogged in the quagmire of waiting time and whatnot. First of all, this is applitools/mono, our Monorepo, and all the packages are inside packages. We have some packages in browser images and other places. Not very interesting. And this is like start of the list. We currently have 55 packages. Actually, that's not true. I've been giving this talk a few times. That was true back then. Now we have 73. Oh, well, that's not true anymore. Again, I gave this talk a few times. Now we have 136 packages. So you see how easy it is for us to just create new packages. Boom, boom, boom. We create new packages, and this is great. And if we have multiple apps, and we do have multiple apps, so the 136 packages are just the packages that I use, okay, then VS Code workspaces are great in that you can create a workspace file which has only the packages that interest you. If you have other packages that other apps use and do not interest you, You just don't put them in the workspace. VS Code workspaces are a godsend for monorepos because and not only that, in VS Code workspaces, each project, from the point of view of all the tooling, the ESLint and whatnot, TypeScript, etc., inside VS Code, each of them is supposedly independent. It is independent. So, wow, VS Code workspaces, thank you for being there. Thank you, Visual Studio Code. So, a day in the life. So, the developer wakes up, comes to work, then they make coffee, talk to their colleagues, then, well, breakfast. Then they talk to the colleagues again. Oh, stop that. It is silly. No, I don't want to talk about that, although, we all know that it's true. It's funny because it's true. Let's talk about the serious stuff. Part the second. The developer wants to fix a bug or maybe write a feature. Okay, so they focus on the package that they need. Okay, let's say it's a bug fix. Let's assume they figured out the bug. Okay, they write the additional code in the package, or fix that if, change a not to a not, and change the and to an or whatever. They add some tests to check the code because there's no other way to check whether that worked. TDD? Oh, come on. If you're working with TDD, then do vice versa, 3 and 4. So you add the test to check the code and then write the additional code. I can't do that. I write the additional code, add some tests, comment out the additional code, and check that the tests fail, put the additional code back, and then make sure it works. That's me. Anyway, the tests pass, time to publish and deploy. And this is part the third. So we've done, we've coded. So we first publish the package into our npm repository, and if it's a microservice, as we said, the Docker image is also published. We git commit because anything we publish has to be committed. We git commit and push actually, and we run npm run deploy. Npm run deploy with the necessary parameters will deploy that microservice, assuming it is a microservice, will deploy that microservice to production. Yes. And we obviously we ensured the deploy works using a production test. So we wait like the 1 minute until the deploy finishes, 30 seconds until the deploy finishes, and then we run the smoke test. Everything happens automatically here. Everything is scripted. It's not like we're doing it manually. We run the production test. If the run production test is okay, we go grab that coffee. And very nice, great success. And this happens many times daily. I mean, sometimes you have a piece of code that takes like a day or 2 days to write, but a lot of times it's, oh yeah, let's change this and to or, boom, deploy, fixed and deployed. I like to write in the ticket. This is frictionless development because we can focus on a very narrow set of code. When we deploy only that code. When we change a package, we change only that code. We run only those tests. Then everything is frictionless. What happens if I have a feature spanning 2 packages? Or what happens if the change was in package B, but package A is a microservice and I need to publish that? So what I do is first I modify, test, publish. I modify the code in package B, test it, publish the code in package B, go to package A, npm update, modify, test, publish code in package A, and we're done. Okay? Or sometimes you want to work simultaneously on both of them. Use npm link. It actually works. On a small scale, it works. You try it on everything, it doesn't. But on a small scale, it always works. And then you publish both packages. First package B, then package A. Remember, we always need to publish the lower packages first. We always build upstream, the lower packages all the way up to the higher packages. And what if there's like a chain of 3 or 4? Unfortunately, we do it manually, and we'll talk about how we deal with that later. npm is our bridge between all packages. As we said, we never do a require on the source. And sometimes we have several major changes that break compatibility. Now, if we do a require on the source and we change backward compatibility, then and somebody else works on that package, boom, they're broken. Semver Major, changing a package to Semver Major allows us to do the change and then make it slowly percolate into the other packages without being worried about backward compatibility, and having all the packages that use that Semver Major new package them slowly use the new major version. Semver Major is an important part of Monorepos and of the way we build. And it's difficult to package development. It's not that difficult once you get used to it, but it's important to note it's not that common. Not that common at all. CI. And I'm going to say something heretical, devil, something very, very heretical. Do we really need CI in a monorepo with those pillars? If a package build, test, publish takes 30 seconds or even 3 minutes, the average is, I think, 2 minutes, do we really need CI? Can't we just run it on our computer? On our computer? Back in the days, no way you run it on your computers. You have stuff that nobody else has. How will I know that other developers use it? Because we're living in JavaScript world and in Docker world. We're not back in the old days, in the 80s and the 90s. Whenever I run an independent package, it has everything it needs to run the tests and build and everything. The Docker images, the tests, whatever is needed is in there. So I know fully well that if it runs on my computer, it runs on the other's computer. And on the rare cases, like once a year that it doesn't, we fix the problem, continue. So yeah, we don't use CI. And yet, we built a build tool for Monorepos. Because in some cases CI makes sense. For example, you need to, when really building it, you need to build a Windows build and a Mac build. You can't do that on your computer. Or remember that I need to build this package and then this package and this package up to the microservice. I don't want to do that manually. Built was built for that. First of all, it runs the steps on a package. Configurable using YAML. All the steps we talked about previously. And it understands the dependency graph. So if it knows that common app code was changed, it knows that after it builds that, it needs to build the upper packages all the way upstream. And it knows which packages to build based on the git commits. So it knows that common app code was changed and it will build all the way up. It just takes care of everything. And for more information, github.com/Gil Tayar/built. That's how it's written. Feel free to start it and participate. It's open source, obviously. CD. And this is all about microservices. I haven't yet had the chance to explore front end and monorepos. Hopefully, next time I do front end, I will be doing that. So in this case, continuous deployment is deployment of microservices and not deployment of front end. I guess it won't be that different. I'm just guessing. Deployments for us are packages too. So if I have microservice A, I have microservice A-deployment. It's Kubernetes YAML files. Okay, passed through mustache templating for the various different environments. So this environment needs one replica of the microservice. That environment needs 300 replicas of that microservice. That's the mustaching thing. And then we just throw the YAML files at Kubernetes and boom, deployment just works. I mean, Kubernetes is amazing in that way. And for me, no Helm, no nothing. I love things that are really, really simple. In this case, it's definitely keeping it simple and stupid. KISS. Deployments are packages too. They have dependencies. It's a whole talk. I'm not going to go into that. There's a price. There's a price for monorepos. Sometimes it's just too good to be true. Why isn't everybody doing it? First of all, it's not yet common practice. I get all that. One repo for all the company's code. What are you, Google? A lot. And it's not yet common practice. People don't know how to do that. And if you don't have somebody like me with 6 years of experience, you don't even know where to start. And frankly, this talk, not enough. Please feel free to email me, talk to me. I can guide you along. Developers are not used to all the code being in one repo. Branches, commits, it's very confusing in a monorepo. It's not that confusing, but it's a bit different. It takes a while to figure it out. CI is not built for monorepos. I mean, it doesn't know how to track the dependencies of the packages in the monorepo. It's hell on earth. But if you need CI, I think most of you don't. But most importantly, developers using small, independent, well-tested packages to build their apps is a totally new methodology. I mean, it's not I mean, everybody is saying modularize your code. And this is a way to modularize your code based on NPM, based on, the heart of JavaScript ecosystem. And everybody's saying that and finishing up with monolithic code. I'm saying we have the capability using NPM, using monorepos, using good testing, and given small, independent, and well-tested packages, we can modularize our application to get that frictionless development, to get that scalable development that everybody's talking about. So yes, again, small, independent, well-tested packages is a totally new methodology. Not a lot of people have tried it, but I've tried it in 2 companies. It's amazing. In summary, the 4 pillars of monorepos: small packages so that they're easily understandable, independent packages so that they're easily understandable and built, tested packages so that if I change anything, I won't be afraid to do that and just publish or deploy that, and uniform builds so that I can go into a package and do whatever I need without trying to figure out how the hell do I need to build and run the tests on it, and so that CI, if you have CI, can just build it. If you have those on a monorepo, you will get frictionless development, scalable development, development that just chugs along in a nice, consistent, predictable manner. Obviously, you also need to be good developers in other areas, but at least you won't be bogged down by the quagmire of managing monolithic and non-modular code. And I'll leave you with these 3 things. Do you want frictionless and scalable development? Yes. No? Well, that's fine. But yes, use small, independent, and well-tested packages. Monorepos are the way to write code that is small, independent, and well-tested as packages. But there is a price to pay for using monorepos currently until the tooling gets better. Be aware of that price. Think if it's worth it. Thank you very much.
Great talk. Great
Thank
talk,
you,
Gil.
Sharon. Had a lot of fun.
I enjoyed it immensely.
Thank you.
So you see the monorepo, multi-repo discussion often in the DevOps sphere,
Yes.
where I'm more active. This is it's a favorite, but I actually hear the pro monorepo much more often than the multi-repo, to be honest. You've got some questions in the chat. I have my own, but we'll start with those. First off, one of the questions was about tooling, like NX and Bazel. Do you have any opinions on those for managing monorepos?
Yep. I built the monorepo tool that we're using. I built because I looked at Bazel, I looked at Lerna, I looked at NX, and frankly, Bazel works. Bazel is exactly what I need. Bazel gives me small independent packages, and it knows how to build it upstream with all the dependencies and everything. Bazel is great, except that it's this huge canon that is so difficult to implement. I've seen a company implementing it. It took them 2 years, and they're not really finished yet. It's so difficult, so configurable, so built for all the use cases in the world. And my use case is simple, like NPM, monorepo, small independent, blah, 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 and we're done. So that is why Bazel is great, but too not kiss for me, not easy. Lerna is too simple. It doesn't, it's not really a monorepo. It's a set of well-connected NPM packages, which you really want to use as basically one. Except that you need to build a lot of packages. That is why Bazel and Lerna itself and Yarn and others are built as monorepos, but because they're well connected between them and they're basically published at one time. It's great for that. But if you want them to be independent, it doesn't work. NX, I don't know. I don't get it. You need it's specific to React. It has plugins for React. It has plugins for this and plugins that, and I don't understand why. Because all I want is, build, test, publish, be done with that. But I've seen people use that for monorepos, and they're pretty happy. So feel free to try it out.
So one of the questions was about code reviews, right? So where does code reviews fit into the mix when you're talking about development and then publishing from your own machine?
And that's a great question. If I'm developing, publishing in Git commit, Git push, then where does the code review happen? And I'm a huge believer in code reviews. I love code reviews. I don't think every commit should have a code review, and I don't think everything should be a pull request or whatever. But there are a lot of stuff, especially in the beginning when a developer enters the team, that need code reviews. And what we do is either they push to a branch and we code review independently if it's like a beginner stuff, or the developer pushes, even deploys, and we do the code review post, because code reviews are not for finding bugs. If you think code reviews are for finding bugs, you have a problem with tests. That is very important. The tests are for finding regressions, and the tests are for finding the bugs in the new code. Code reviews are to see whether this could have been improved, refactored, etc. And we can do that post, and we do that post push, actually. And we find things to review, and then the developer fixes them and does another push, and we're done. So I love code reviews, but we do them post factum.
Okay, 2 more questions, funny ones. So in the context of science fiction, sci-fi, is this not sci-fi? I mean, is it really practically applicable to do all of these things within a monorepo? It's kind of like refactoring code. It's kind of like all of these things that are always in the backlog, technical debt. Can you really maintain independent packages? Can you really have them so well tested? Can you do all of these things in such a large organization? And in a small organization, I can see that it's possible. But when you get to like large organizations, and I think that that's wherein the problem lies. That's why many times companies move from monorepos to multi-repos, just because of that. It seems like an overhead that's hard to maintain.
Right, and I totally agree, and I have to admit, well, I've tried monorepos in a large company at Wix, and there, in the end, what monorepo, Wix doesn't do a lot of monorepos. It just one monorepo just does a lot of monorepos. What happens in a larger scale company is that the packages tend to be clustered. So it's not everybody using every other packages, which is unscalable, but like a lot of packages here are using each other because it's the same team or the same set of microservices. And then this team is using like 1 or 2 packages from here. So you got clusters of packages, and each cluster, and it's fractal. Sometimes there's clusters of clusters and everything, just like the universe is built. So it's fractal, and each level has its own scalability and independability. The first level has a package independability. The second level has a cluster independability, etc., as you go up. Have I tried this in a huge monorepo kind of a thing with a large company? I hopefully will, and then who knows? But currently, it's not tested. It is tested in the medium-sized company that Applitools is, and it's well tested, and it works amazingly well.
I like your hand motions. They're very engaging. And very last one, just for fun. If you were an NPM command, which one would you be?
An NPM command? Oh.
That's courtesy of Liran Tal, by the way. That's a run script command. Sorry.
NPM CI. NPM CI. And the reason
because you love CI so much.
No. NPM CI deletes everything and rebuilds all the packages once again. And if I could do that with my psychology, like remove all the bugs and stuff and just have all the dependencies work again, that would be a perfect solution for me.
That's awesome. Okay, folks, if you enjoyed Gil's talk, definitely rate it. He wants to know how he did. It's important. We like to know and improve. And so the link is in the chat in Hopin. And thank you, Gil. It was a pleasure having you, Guru Gil.
Being there.
If you want to know about sci-fi, he's your person too, by the way, not just Monorepos.
Go see the Dune movie.
Oh.